Okay, so we're still working on systems of equation. Remember, systems of equations are two or more equations, and today we're going to look at a method called substitution. All right, substitution method is a method of solving a system of equations by substituting equations within each other. All right, here are the steps for solving using substitution. Step 1, you're going to solve one equation for x or y. So you can solve for either variable, whichever is the easiest. Then you're going to substitute this expression into the other equation. Okay, so the other equation. So if you solve for x in equation 1, then you're going to plug that into equation 2 later, or vice versa. Step 3, you're going to substitute your answer into the revised equation from step 1 and solve for the other variable. So remember to always come back and solve for the second variable. All right, so let's look at some examples here. All right, so example 1, solve each system by substitution. All right, so we have two equations and they have the same two variables. All right, so that means that we can solve this using substitution. All right, so I'm going to start by calling this equation 1 and the second one equation 2. All right, now if I know that y is equal to 4x minus 1, then I can substitute that in my other equation and solve. If I put 4x minus 1 in for y, that means I'll only have one variable in the second equation. So we're going to start with 4x minus 1 equals 2x minus 5. Then I have x to solve for, and I'm going to subtract 2x from both sides. All right, and then I'm going to move up here a little bit. I'm running out of room. 2x minus 1 equals negative 5. Then I'm going to add 1. And I have 2x equals negative 4. Divide by 2. You're dividing a negative by a positive, so we're going to have a negative 2. All right, so we found x. Now we need to find y, because remember, when you're solving for a system, it's an ordered pair that makes the system work. So we need to find the y value. All right, so how do we do that? Let's change colors here. So we have x equals negative 2. And if we have x equals negative 2, we can choose either equation. Let's go back to equation 1 since we were working with equation 2 here. And let's put in negative 2. You really can use either equation here because we just need to find the y value. So y equals 4 times negative 2 minus 1. And all I did was take this equation and substitute my x value for that. So y equals 4 times negative 2 is negative 8 minus 1. Y equals negative 9. So that is my y value. Now the answer or the solution to the system is the ordered pair that makes both equations true. So our ordered pair is going to be x and y. We always have an x and a y. That's our ordered pair. And then you're going to check to see if it works. Okay, so let's come over here in the side to see if it works. So my y value is negative 9. So for equation 1, I'm going to say, does negative 9 equal 4 times negative 2 minus 1? Okay, and let's put a question mark there because that's what we're trying to find out. So we've got negative 8 minus 1, which is negative 9. Well, I wrote a 9 instead of a 1. My hand was going faster than my brain. There we go. So 4 times negative 2 is negative 8. Bring down the negative 1. Negative 8 minus 1 is negative 9. So negative 9 equals negative 9. So the first equation checks. And let's check the second equation just to make sure as well. So I've got y, which is negative 9. Does that equal 2 times x? X is negative 2. And then the second equation has a minus 5. All right, so negative 9 we've got 2 times negative 2, which is negative 4 minus 5, and again that works. So when you plug it back in to check it, both equations work. All right, example 2. Again, I'm going to start by labeling these as equation 1 and equation 2. All right, you can choose either equation to solve for and then substitute. Since this one already has y by itself, it makes sense to take y equals 6x and substitute that in for y in my second equation. Again, if I substitute 6x in for y, now my second equation only has x, which means that we can solve it. So let's bring down the 2x plus 3, and then I'm going to plug in place of y, I'm going to substitute the 6x. And then that equals negative 20. All right, so I took the second equation, 2x plus 3, and I'm going to substitute for y the 6x from the first equation. All right, so I'm going to have 2x. 3 times 6 is 18x equals negative 20. 2 and 18 make 20x equals negative 20. Divide by 20, x equals negative 1. All right, again, I found x. We still have to find y. Well, very easily in the first equation, y equals 6 times x. So if y equals 6 times x, and now we know x is negative 1, y is 6 times negative 1, or negative 6. So my ordered pair is negative 1 and negative 6. Remember, it's always x and y. It doesn't matter which variable you solve for first, but it does matter which variable goes in the ordered pair first. It's always your x and your y. All right, then you're going to substitute in and see if you can check it. And let's do that over here to the left again. So my y value is negative 6. So equation 1 says, does negative 6 equal 6 times x? And x is negative 1. So that one works. And then equation 2 says 2 times x plus 3 times y equals negative 20. And then 2 times x, I know my x is negative 1 and my y is negative 6. So I'm going to have 2 times negative 1 is negative 2 plus negative 18. And if I add 2 negatives, it becomes a bigger negative. So negative 20 equals negative 20. That works as well. So my ordered pair, or my solution to this system, is negative 1, negative 6. So that point lies on both equations. And it is the intersection of the two equations. All right, I'm going to go through number 3 kind of quickly. It's just like number 2. I've got 2 equations, equation 1 and equation 2. Y equals x plus 9. So I'm going to take the x plus 9 and plug it in for my y. Y equals this, so I can substitute this in place of y. So I'm going to have 3x plus 8y equals negative 5. In place of y, I'm going to substitute x plus 9. Now I'm going to put that in parentheses because y equals all of this, and I need to distribute that 8. So make sure you put that in parentheses so that you don't just have 8x plus 9. You have to distribute that, okay? All right, so now we're going to bring down the 3x, and then when we distribute, we have 8 times x, and we have 8 times 9. So again, you don't want to have just the 9 there. You have to make sure you distribute that 8. All right, 3 plus 8. These are on the same side, so we're combining like terms. 3 plus 8 is 11x plus 72 equals negative 5. And then I'm going to bring that up here. So I've got 11x plus 72 equals negative 5. And I'm going to subtract 72 from both sides. If I subtract 72, I have a minus 5 and a minus 72, which is minus 77. Divide by 11. X equals negative 7. All right, we found x. You still have to find y. Remember, you always need an ordered pair. So I'm going to have y equals, my first equation says x plus 9. So I've got x plus 9. Now I know that my x is negative 7. So negative 7 plus 9 is positive 2. All right, again, I need an ordered pair. Negative 7, 2, and you need to check it. So let's check it very quickly here. So take negative 7 plus 9 is 2. It works for number 1. In the second equation, if I take 3 times negative 7, that's negative 21, plus 8 times 2, which is 16. Negative 21 plus 16 is negative 5. So this works. That is a point on each equation, and that is the intersection point of the two equations, which is the solution to the system. All right, example 4. This time we have x equals. So if x equals 4y plus 7, this time we're going to substitute in place of x. All right, so x equals 4y plus 7. Let's take 2. We're going to leave a big space here because we've got to put all of that in this parentheses here. So 2 times x minus 6y equals 12. And then in place of the parentheses, I'm going to put the 4y plus 7. All right, now distribute the 2. 2 times 4y is 8y, and 2 times 7 is 14. And then I have minus 6y equals 12. Now we're solving an equation. We have 8y and negative 6y on the same side, so we're combining like terms to get 2y plus 14 equals 12. Subtract 14. 2y equals negative 2. So y equals negative 1. All right, so this time we found y first. So we can go ahead for our ordered pair. We know it's x and y. So our y is going to be the second number. So now we have to find x. So if we go back to the first equation here, x equals 4 times y plus 7. So I'm going to take y, which is negative 1, substitute that here. X equals negative 4 plus 7. So x is negative 4 plus 7, or positive 3. So x is 3, y is negative 1, and we need to check it. All right, so for equation 1, x is 3, and y is negative 1. So we're going to have 4 times negative 1 plus 7. So we're trying to see if this is true. That becomes negative 4 plus 7, which is negative, nope, that is negative 4 plus 7 is positive 3. So 3 equals 3. The first one works. Let's check the second equation. 2 times x minus 6 times y. Does that equal 12? All right, 2 times x is 3. Y is negative 1. And that gives us 6. Negative 6 times negative 1 is plus 6. And that equals 12. So that one works as well. All right, so I hope you see that what you're doing is solving for one variable, plugging that into the, or substituting, plugging or substituting into the other equation, and then solving for the second variable. So you're always going to have an ordered pair here, and your ordered pair is your solution. That's the point where the two lines intersect, just like where we were graphing, and it's a point on each equation of this system.